Today we will discuss the normal distribution. So I'm going to warn you now, you will need your calculator for this. Please work through all the examples on your calculator as I go through them also. So below you can see a histogram that shows the distribution of batting averages for Major League Baseball players. And you'll notice that the distribution is fairly symmetric, it's fairly unimodal, and actually it's a really good distribution because you can draw this nice bell-shaped curve on it. And we call this curve a normal distribution. You can also call it a normal curve. And you'll find that many things in nature and other things like batting averages follow this distribution. And the other thing that we like to say is that the distribution of batting averages is approximately normal. So the reason I want to emphasize this is because if you were taking the AP test and you were to say that this histogram was normal, believe it or not, they would mark off points for you for that. You would have to use the word approximately just to show that it's not perfect. We pretty much never get a perfectly normal distribution, but most of them are approximately normal, and that's what we're going to be working with. The other thing that's important is that the area under this curve and any other curve that we get, we're going to get one called the chi-squared in the future. The area is always going to be 1. And most people like to think of this as something like 100%. And this area helps us determine what proportion of the values in the distribution are in certain places. So for example, if you were to cut this thing exactly in the middle, it's around, the mean looks like it's around like 0.26 or so, maybe it's 0.25. But if you were to cut it exactly in the middle, you would find out that 50% of the values would be to the left of the mean and 50% would be to the right. So the other thing that's important, and I kind of just touched on that, is that the middle part of this, which is where this green line is going to represent your mean. So like I said, it's about 0.26 or so. So one of the most important things that you encounter in this class is the 68, 95, 99.7 rule. Sometimes it's also called the empirical rule, but we'll just call it this so you can try to remember the numbers. And they have like a nice explanation in every stats book you ever see, but I'll draw a picture and I think that'll help us understand. So when you have a normally distributed population, the middle number of it is always going to be the mean, which I'm going to write as mu. And if you go one standard deviation away from the mean, which I'm going to write the standard deviation as a lowercase sigma, I'm just going to write SD for now. So within one standard deviation from the mean, which means that, this is 1 SD, that within this area here, 68% of the population will be in that area. So if you look at the example that I just had on the previous page, what this means is that our standard deviation is always going to be, it's always around where the curve changes from concave down to concave up. So we can say that this part where I put the green arrow is within one standard deviation of the mean, which is around there. And that's where about 68% of our values are going to be. So now if you go 2 standard deviations away from the mean, in that area, about 95% of our values are going to be there. So if you were to look at our batting average example, We know that about 68% of the batting averages fall between about 0.22 and 0.3. So 95% are going to fall between about 0.18 and 0.32 or so. And then finally, if you go all the way 3 standard deviations away from the mean, that is going to be 99.7% of all the population. So in this one, we can say that out of all baseball players that were used in this example, 99.7% of them have batting averages between about 0.15 and 0.35. So there's very few that are outside of that range. So that's basically what the normal model will tell us. So let's use the baseball example, and I'm going to go into it in a little bit more detail, and we're going to get the exact values. So here they're telling us that the mean was 0.261 and the standard deviation was 0.034. And one thing that I would like to point out is that you'll notice that my mean here uses the Greek letter mu. The reason for that is that because this is what we call the population mean. So we're looking at all of these baseball players. The same thing, you'll notice that my standard deviation uses the Greek letter sigma instead of the S that we sometimes use. The reason for that is because that is my population standard deviation. So let's go ahead and sketch the normal curve. And it takes a while to get the hang of these. If you want, you can actually go online and print out blank copies of the normal curve because you'll be drawing them occasionally. I won't try to make you do too much where you draw it because I know sometimes drawing it is hard. So this normal curve is definitely far from perfect, but you can just do the best that you can. So whenever you have a normal curve, the first thing you're going to do is you're always going to put the mean in the middle. So my mean is 0.261. Then the middle 68% of values are going to be all 1 standard deviation away. So I'm going to find the value here by doing 0.261 plus 0.034, and that will give me 0.295. And I'm going to find the value here by doing 0.261 minus 0.034, and that gives me the value 0.227. So now I'm going to do the same thing to find the middle 95%. So now I'm going to take the 0.295 I got in the previous thing, add my standard deviation, which is 0.034. I get 0.329. Do the same thing, subtract, and you'll get 0.193. Then you are going to subtract 0.034 and add 0.034, and you get 0.159 and 0.363. So it might be easier on you if you do different colors. This part right here is going to be 95%. If you can fit the 99.7 in there, that's great. If not, just do it below. You do not need to be perfect at drawing these. It's more important that you're able to do the calculations. So the number one thing I told you, I think in a different video, is that you always need to label. So make sure that you give it a title. I'm just going to call it batting averages. So now let's go on to a few examples. So we're now going to we're going to answer a few questions about this distribution. And the first two we're actually going to do by hand. The next ones we're going to use a really wonderful function of the calculator. So the first thing they're asking you is what percent of the batting averages are above 32.9%. So if you notice, 32.9% is actually listed on our normal model, which is great. So we know that the middle 95% is between 0.193 and 0.329. So that means that if we were to add up these three arrows that I have, they would add up to 100%. And that means that this arrow and this arrow are going to add up to 5%. So then greater than 0.329%, I'm going to draw a little model right here. This part right here is actually going to be half of 5%, so it's going to be 2.5%. So the next one's another kind of fun one. So we want to know what percent are between 0.193 and 0.295. So to figure this problem out, you're going to have to use a little bit of fun math. So we know that between 0.193 and 0.329, this area is 95%. By the way, just a side note, just to make a clarification in case you weren't sure, that is the whole the 95% or 0.95 is the whole entire shaded area of this part. So that tells us that 95% of batting averages are between 0.193 and 0.329. We also know that between 0.227 and 0.295 is 68%. So now, the only thing I need to figure out is what is the area of this purple part right here. And you're actually gonna find out that it's everything except for this part right here. So what we can do is we can try to figure out what is this part here. And actually, to help us out, we're going to also find out that other yellow part that I have. So we know that these two things right here are going to, and 68, are going to add up to 95. So we can find the area of both of those yellows by doing 95 minus 68. When we do that, we end up getting 27. So then we know that that little part in yellow right here is going to be half of 27. And half of 27 is 13.5. So now what we're going to do is the part that I have shaded in pink is 95%. The part that I have shaded in yellow is 13.5. In order to get the purple part, there's lots of colors here, so hopefully you're following. If you're not, you can just ask me in class. We are going to find out that purple area by doing 95 minus 13.5. And that is going to give us 81.5%. By the way, there's several ways that you can do this. You can also add 13.5 to 68. That'll get you the same answer. But there's a few different ways to do it. And now that we did all that work, I'm actually going to tell you there is an easier and faster way to do this on your calculator, and in the future you're probably going to be only using that way. But I wanted to show you this just to give you an idea of what's going on here.